dear children, today we are going to discuss what is the geometrical representation of zeros of the polynomial. Okay, it is also called as a graphical representation. Now you know that the polynomials, linear polynomial and quadratic polynomial. Now how to represent this linear polynomial? You know that very well. Whenever there is a linear polynomial in one variable like this, it is the standard form, that is p of x is equal to ax plus b, where a not equal to 0. This is a generalized form of the linear polynomial. Let that p of x is equal to y to plot on the graph. So here what is y is equal to ax plus b. For example, we will take p of x is given as 2x plus 1. Okay. Now let that p of x is equal to y, that is y is equal to 2x plus 1. Now we know that how to plot the linear equation in two variable. This is in two variable, okay, but polynomial in x. So put the values of x, you will get the value of y. If you put here x is equal to 0, definitely you will get this term 0, therefore y is equal to 1. If you put x is equal to 1, you will get y is equal to 3. You can solve. And if you put here x is equal to 2, 2 2s are 4 plus 1 5. Means you got the point, coordinate point 0 1, 1 3, 2 5. Now we are going to plot this point. Now this is 0 1. 0 1 means this one point, this is the coordinate 0 1. Okay. Now what is 1 3? 1 and here 3. This point is 1 comma 3. Now 2 5. 2 and this is the 5. This point is 2 5. And if you join this point, you will get that straight line. This is nothing but the geometrical representation of this polynomial. Means for geometric representation of linear polynomial is straight line. But what we are talking about in this video, we are talking about what is the zero of this polynomial and how it is represented on this x-axis. Now you know that if you solve 2x, if you want to find the zero, you are going to calculate, equate it. 2x is equal to 2x plus 1 equal to 0 to find the 0. Therefore x is equal to minus 1 by 2. Means this x is equal to minus 2 by, means point of intersection is minus 1 by 2 and 0. This line will intersect exactly here. There it is the 1 half, that is 1 half minor. Means this is how whenever this line intersect at x-axis, that is the zero of this given polynomial. You can observe this. Means if you draw the straight line and if it intersect the x-axis in which point, that will be the zero of this linear polynomial. Means in general, linear polynomial ax plus b has only one zero. As you can observe that this line is intersecting this x-axis at only one point, that is minus 1 by 2. Okay, so the straight line y is equal to ax plus b, in general we are talking intersect x-axis at minus b by a 0. Here minus b by a is, here our minus 1 half. Sometimes you will get the real number also. So this is how the geometrically the zero of linear polynomial represented on the graph. Means you can verify that the linear polynomial of the form ax plus b have only one zero, that is minus b by a 0. Now what about the quadratic polynomial? Now let us see the example. We will take the example and then we will generalize it. Okay. Now the quadratic polynomial x square minus 3x minus 4. Now here we are going to plot some more points. So you have to do this on the graph paper. So exactly you will get the point. If so, again p of x will represent it. We take as a y. So y is equal to x square minus 3x minus 4. Now put the value of x, you will get the value of y. So I have put it here, x is equal to 5. So after solving this, I will get x is equal to 6. If I put x is equal to 4, I will get y equal to 0. And like that, if I put the value 0, 1, 2, minus 1, minus 2 in this and at the value of x, I will get the respective value of y. And then we are going to plot that points on this Cartesian plane. Now first point is 5, 6. 5, 6. This is your 5, 6. Okay. Now next point is 4, 0. Means x-axis 4 and 0. That point will here only. 4 as x coordinate is 0. Now next 0, 4. 0 means 4 means it will be on y-axis. That is 0, 4. This will be the 0, 4 point. 1 minus 6. 1 minus this one is point. 1 minus 6. Now 2 minus 6. This is the 2 and here the point is 2 minus 6. Minus 1, 0. Here is a minus 1. Okay. Minus 1, 0 means this will be the this point. Okay. And minus 2, 6. This one point. Okay. Minus 2 and 6. Minus 2 and 6. And if you join these all the points free-handedly, you will get some curve like this. If you join these all points. It is not up to the scale. If you draw it up to the scale, you will get exactly this like this shape. Either if for this polynomial you got like this, somewhere you got like this, and these shapes are called as a parabola. Means what you observe for any quadratic polynomial, if you draw the plot the points like this, you will get the definitely like this shape, either like this, okay, or like this. These are the shapes. So these are called the parabolas. Now depending upon the coefficient of x square, depending upon the coefficient of x square, this either this figure you will get this upward, it is called as a upward parabola, upward parabola, or this is called as a downward parabola. Means if your a is nothing but coefficient of x square is greater than 0, then you will get always upward parabola. And if your coefficient of x is less than 0, means it is negative. Less than 0 means negative. This parabola you will get a downward parabola. In the quadratic polynomial, there are some cases that we will. Now let us see some cases. Now if the graph, means the parabola graph, cuts the x-axis at two distinct points as shown in here, a dash, a, suppose this is p, q, another graph will be there, r, s, like this. Here all the diagram you can observe that this graph intersect the x-axis at two distinct points. Means then this polynomial will have two zeros. We have two zeros which are real and distinct. And what are that zero? That zeros are x coordinate of these two distinct points. Suppose x coordinate of this a dash is minus x0 because it is on the left hand side, and x coordinate is x0. Then what are the zeros of this polynomial? Minus x and x. These two are the zeros. Suppose ab, if you take a as a real number any, this is minus a and a are the zeros of this quadratic polynomial. These all cases have the two distinct and real zeros. Now let us see the second case. If the graph is like this, either like this, means this is the graph just touching to the x-axis here, or either like this, in this quadrant like this, or in this quadrant like this, or either on downward parabola like this, just touches the x-axis. that time this quadratic, this is again quadratic polynomial having only one zero we are looking, but having again two zeros which are equal, because this point is coincide there. For example, you take the x square minus 2x plus 1, then this will definitely have this type of zeros, because these zeros are coincide here. Here these two zeros are coincide there, means having two zeros but that are equal. In all cases, if that graph just touches the x-axis, that time that polynomial have two zeros but that are equal, which are coincide on each other. Now last case, if parabola does not intersect or does not touch the x-axis, means what? If the graph is not touching or not intersecting the x-axis, that means that polynomial have no zeros. This you have to keep in mind. Means what? If you will get the graph like this or like this, these parabolas are not intersecting the x-axis anywhere, because it is your x-axis. So this polynomial don't have any zero. This is all about the quadratic polynomial. Let's see what about the cubic polynomial. Now what are the cases with the cubic polynomial? If you take any cubic polynomial and represent the graphical representation, you will get some of like this type of the examples. So what are the zeros of polynomial? According to the diagram, by observing only the graph, whenever this curve or that graph intersect the x-axis, that many zeros are there. Only keep in mind, जितने जगह x-axis को intersect करता है उतने zeros होते हैं, और जितने zeros होते हैं उस हिसाब से हम उस polynomial का type भी बता सकते हैं. Now as this graph intersect at 1, 2 and 3, all three are the distinct point, means this is the cubic polynomial having all three distinct zeros. Whatever the x coordinate of this point A, B and C. Suppose this x coordinate is minus A 0, B is minus B 0, as I am taking only real number because this is the negative sign, and this is C 0, means that minus A, minus B and C are the roots of or the zeros of this cubic polynomial. Now if you observe here, you are seeing that this graph just intersect x-axis, and here this curve touches, means whenever this curve touches, that means there are two equal zeros and this is one distinct point. Again this is the cubic polynomial as 1, and there are 2 points, as whenever the curve touches, just touches, that means that have two zeros. Okay, now here like this also condition can be there. Here just this curve touches to the x-axis, so here are two equal zeros, and now this curve intersect, so there is one distinct. This is one of the possibility of the cubic polynomial. Means just observing the graph and how it is touches or intersect to the x-axis, you can directly say that graph is of either quadratic or linear or cubic.